All right, everybody, welcome. I am really proud of you. I think this is we're doing the best we can, and we're doing pretty good actually. Um, I'm going to be sending out a Google form later on to see who's going to be taking IM3 and who is just going to finish for this IM2 and be done. This way, I know how to support you. Okay. I did apply to teach IM3 for next terms, so we'll see how that works. Pretty sure it'll be okay. So today we're going to do something that's going to start today. You're going to finish it tomorrow. So after today, I'll let you guys do the assignment for 2 days. So I won't see you tomorrow, and give you guys plenty of time to practice. All right, so let's start with this idea. I assume you can hear me. Somebody answer me.
Yeah.
Oh, thank you. Yeah. Thank you. All right, so we're gonna go through the 3 forms of quadratics, and today we're gonna focus on one of them. Okay, so let me try to get my. I'm gonna put my computer flat so I can write really good. Hang on 1 second. Let me turn this off. I don't think I need to see my. Okay, so I put my screen off. Hang on. Give me 1 second. I don't need to, the camera's going to be facing the ceiling. Let me just turn that off. I don't need to see that. Okay, there we go. All right, so let's start with factored form. And basically, we're going to make a triangle. Okay, so but don't worry about making the triangle yet. So right in the middle, let's do a factored form. X plus 2, times x minus, 6. We'll keep it real simple, okay? Y equals. Okay, so this is factored. Okay. So what's easy about factors? Can you guys help me out? What's easy to determine from factored form? What's easy?
Well, for one thing, like one easy thing you can do is like doing that 4 squared thing, like.
Yeah, right. Yeah, you can convert it to standard form, right? Well, let me give you a multiple choice. Are the x-intercepts, y-intercept, or vertex easy to determine from factored form? X-intercepts. Okay, x-intercepts. And Amar, what are they?
-2, 6.
-2 and 6. Okay, cool. So that's easy. No? All right, next. Let's convert this. I'm going to change colors. And I think I heard Travis say we can do the box. Let's convert this to standard form. Standard. And so we need to make a box, right? I'll go back to green. Okay. X2, x minus 6. So we're going to get, I'm going to put this in red, x squared, 2x, -6x, and then -12. So standard form is going to be x squared, then you got to combine these two right here, minus 4x minus 12. This is standard form. All right, guys, what's easy to find on standard form? X-intercepts, y-intercept, or vertex? What's easy to determine?
Y-intercept.
Y-intercept, okay. And what would that be, Nathan?
-12.
Yeah, -12. And I'm actually going to say 0, -12. Like I should have said over here a -2, 0, right? I should have said -2, 0, and then 6, 0. Okay. All right. So we need to. We're missing one more, the vertex form. Now, I I wanted to show you guys something, a little trick that I used to use when I was your age. Do you guys want me to show you that, or you want to do it the long way to find the vertex? What would you like? The long way or the?
Order way.
Okay, all right. What way was that? I didn't catch that. Vertex. All right, short way. Okay, all right.
Guess, maybe make this lesson
Yeah. Got it. All right, ready? So I used to do this, and then my friends in the class, they would always take a long time to get the vertex, and then my teacher would get mad at me because I wouldn't show my work. Now, I could tell you what the vertex is just by looking at the x-intercepts. By the way, how far are the x-intercepts? Well, how far apart are they? So how far apart is 6 from negative 2? 6 from negative 2. Cool. So what's half of 8?
4.
4. So I would just square 4, and I would get 16. And it's going to go down. So it's going to be negative 16. And you said it's 4 away. So that's going to be at 2. So it's going to be 2 comma 16. That's weird. So basically, I would find out how far the x-intercepts are, right? Make sense? And then I would find the middle. How far apart are they? So they're 8. That means they're 4 apart from each other, right? And then I would get 4 squared, and I know this graph's going to go down because the steps are going up. So let's prove it. Let's do the long way. So we know that the vertex is going to be at 2. You guys agree with that already? Am I okay with that? We know that 2 is where the middle of 4 and I'm sorry, that's the middle of 6 and negative 2. So what do we got to do with 2? What do we got to do with this number? We got to plug it in. So we have to plug it in. So let me use, I was using blue. I'm going to stick with my colors, just even though it's going to take some time. Hold on. I guess I don't know how to erase. Okay. Maybe this one. There we go. All right. So you got to plug in 2. Can you guys plug in 2 for the x's and then find out what the vertex is? While I figure out my... So you're going to... I said that it's going to be negative 16. That was my guess, right? So you're going to plug in 2 here and 2 here. So it's going to be 2 plus 2 times 2 minus 6. What is this equal to? 4 times negative 4, and that equals what? Anyway, so you don't have to do it my way because, I was just lazy. I would skip this. I would just do it in my head. We'll try a few, and if you like it, use it. If you don't like it, just plug it in. It's okay, no big deal, right? Okay, so how do you find the vertex? You find the middle of the x-intercepts and you plug it in, right? Or you could do like me, find how far the middle is. Does that make sense? And then square it. Then square it. It's probably going to be negative if it's going down. It'll be positive if it's going up. Nathan, do you think you would try this method? Just find out how far is the middle, and then square it, and then that's going to be your vertex. That's going to be the y of the vertex, right? Okay. So we have all three methods. So today we are going to focus on going from red to blue. Oh, red to blue. We're going from here and ending up here. This is our focus today. From standard to vertex. But in order to do, can somebody give me the equation for my vertex? Y equals what? Y equals what? I'll give you a hint.
X minus 2 squared
X
minus 16.
Yep, x minus 2 quantity squared minus 16. This is the equation, right? So we kind of went backwards. This one we found the vertex, and then from the vertex we found the equation. But from the equation we can find the vertex, right? We can go back and forth. All right, so in order to go from red to blue, I first want to show you guys how to go from blue to red. So in order to go this way, first I want to show you how to go this way. Okay, all right, let me make some space here. Now go real slow here, okay? X minus 2 squared minus 16. Okay, so what we could do is we can make a box with a set of twins. And why do I call them a set of identical twins? So 16 is outside, okay? So because they're the same numbers. Look, they're the same exact thing. So we're going to go x squared. Oh, actually, I'm going to put that in red because we're going to go from blue to red. So I'm going to go red here. Red means standard form, right? X squared minus 2x plus 4. And then, so now we can combine these two. So we get x squared minus 4x plus 4, and then minus 16. Don't forget that minus 16. So now we can combine these two right here. So what do we get? We get standard form. Okay, so that's how you go from vertex form to standard form. How do you think we do it the other way around? What do you think? Do you think you just do it the opposite way? Yep, you would do it just the reverse, okay? So now, from standard to vertex. All right, this is today's lesson right here. So we do this in reverse. All right, so we start with standard, okay? X squared, 4x minus 12. Now, I showed you guys that bicycle video of that kid riding his bicycle backwards for a reason. All right, what you want to do here is you want to make, all right, I'm going to slow down right here. You want to make a perfect square. And you want twins. You want twins here. And you want these to be twins. Now, these two have to add up to -4. And they're twins. So what two numbers are the same number and add up to -4? So like, for example, -3 and -1 add up to -4, but they are not twins. -2. And why do we want twins? Because that's what vertex form has. Does that make sense? So leave this blank. Leave this spot blank. Okay, now fill out the outside. X, -2, -2. Now you could fill in the missing. I'm going to change it to green. What number will this become?
4.
4. But it's not supposed to be 4. It's supposed to be -16. So how can we force 4 to become -16? What do we got to do? I'm sorry, not -16. Darn it, I gave you guys the answer. -12. Dang it.
-16.
Yes, thank you. Yeah, sorry. My brain was one step. So we have to add -16. We can make another square. Now, these combined become -12. So now we have our twins. We got our twins, x minus 2 squared, right? And then these guys combined will give us the extra number, which is -12. Bam. That's how you find vertex form. Oh, wait, hold up. Not my mistake. I was celebrating too fast. -16. The same number that you had the number you had to force, right? Not 12. Dang, I hate when I celebrate too fast. All right, let's try another one because I think I goofed up at the end. I didn't stick my landing. All right. We're gonna do a standard form, and then you guys make it up, but I'll see if it works. Okay, we're gonna go from standard form. All right, give me an even number to put in the middle, positive or negative. What would you like? We already used 4, so try something else. Give me some other number.
8.
All right, cool. Let's put +8, 8x, and then give me I don't know, a positive number here. Anything.
19.
Very good. Okay. So let me, I'm going to make sure that it does, actually, it doesn't really matter because 19. All right. So let's make our twins. We're going to make our twins. And we want twins because vertex form has twins. So we're going to have x squared here. Now these two have to add up to 8. And they're twins. So what number are they? 4x and 4x. Okay, that's supposed to be blue. Cool. Now this becomes 16 here, but it's supposed to be 19.
+3 like on the side of the square.
Yes, +3 on the side, which means these two combined have to equal that. So we're going to force it, right? We're just going to like tweak it. So therefore, our vertex is x plus 4 squared plus 3. And let's see if that is true. Can you guys jump on decimals and type it in there? X squared, xx plus 8x, and then plus, you said 19, right? All right. So what is that? Negative 4, 3. And look. So what is the vertex? Yay. What are you guys saying? Is this difficult? Okay. All right. I'm going to do one last one, and then we'll do the Desmos, and then I'll sign the Khan Academy, and you guys will have 2 days to do this, okay? I actually think it's kind of cool, because it's like, oh, standard form needs to be vertex. I need twins. I can make twins. You can force any equation to be any number, right? All right. Let's try one that has letters, okay? Actually, no. Before the letters, let's do a number. Okay. Let's do 3x squared minus 9x plus 7. Okay. And we'll make it a function, y equals. Okay. Now, when they have an extra number in the front, you need to get rid of it. How can you get rid of multiplication? How do you get rid of multiplication? Divide. So we divide everything by 3 first, because we need twins. Remember, twins don't have an extra number here. So we're going to divide by 3. Okay. So, and you divide this by 3, which is whatever, right? Okay. So you're going to get x squared. 1 second. 3 times x squared minus 3x plus, you know what, let's change that 7 to 21 just to make it easy for my example. Otherwise, we're going to have too many decimals, which is fine, but for an example, it's easier to do this. Does that make sense? Okay, now we can make twins. 3 times, now notice how I have the 3. I still have the 3 out here, right? Let's make our twins. All right, what 2 numbers add up to negative 3? And are twins? Negative 1.5. Right? Because these have to add up to this number right there. So that means we know our twins. All right. Now this number, 1.5 times 1.5 is 2.25. But it's the wrong number. It's supposed to be 7. So we need to have an extra box out here. So how much do we have to add to 2 1/4 to become 7? Well, let's pretend it was $2.
4.75.
475, yep. So we have our twins. And so we have 3 times the twins. And then what you added here. And this is the function. Oh, by the way, what's the vertex of this thing? What's the vertex? What can you slide into x to get rid of negative 1.5?
1.5.
Yeah, 1.5, comma 4.75, right? All right, let's verify that. Okay. Anybody need me to hold on for a second? I can slow down. No problem. This blew my mind when I learned this. I was like, what? Let's see. We had 3x squared, right? I think we had minus 6, minus 9x, and then minus 21, right? All right. Is that right? Oh, I made a mistake. One little.
Instead of an x squared.
Yeah, look at this mistake. Ready? Check it out. Let's pretend it is on purpose, but I totally forgot. So see this 3 times this. Well, we need to also, if we added 4.75, it's actually 3 times 4.75. So what is 3 times 4.75? So we're really adding 3 sets of these. Does anybody have a calculator? What's 4.75 times 3?
I think it's like 13.5.
All right, let's try that. I even use Desmos, right? What is 3 times 4.75? So yeah, 14 and a quarter, right? So 14 and a quarter. 1 second here. Hold up. This did I miss up? 3, negative 9, negative 21. This vertex is, we got the x right, but this is actually 27.75. 7. Hold up. Negative 3x squared, negative 9x. Oh, I got it. I put minus 21. It's supposed to be what? Plus 21. Okay, let's see what this one's at. So there it is. There we go. So it's 14 and a quarter. Okay. So I made a mistake by typing in a negative in the wrong spot. So here's the important thing. When you are adding this extra piece, if there's a number out here, you have to multiply it because there's 3 sets of these for this case, right? Times 3, whatever you started with, okay? All right, so this vertex was actually 1.5 comma 14.25. All right, here we go. All right, this is the last one, and this is going to be only letters. A x squared plus b x. Just pretend they're letters, right? Pretend they're numbers. A is a number, any number, and then b is some other number, and then c is some other number. All right, so who has to leave first? Bye. How do you get rid of the a? Divide by a. Bye-bye. So now you have y equals a times x squared plus bax plus ca. All right, now we got twins time. And I'm only going to do half of this because it's going to like blow your brain a little bit. All right, these two have to add up to this, and they are twins. So what number is it? What if the number was 20? What would the number be? What would be inside? They're twins. What two numbers add up to 20?
Oh, 10 and 10.
10 and 10. And they're twins, right? What if there was 30? What numbers would they be?
15 and 15.
15 and 15. So you're getting half of it, right? So how do we get half of BA? Like this. Half. So we do know the twins. The twins are x plus BA squared, then plus something. We don't have to worry about this piece right now. What's the vertex of this equation? What's the x of the vertex? What do you think, Nathan? What would get rid of b over 2a?
Negative b over 2a.
That's right. And that's the formula that I showed you guys a long time ago. Remember that? Remember a while back I said, oh, if you have standard form, if you have the opposite of b over 2a, that's your x of vertex.
Yeah.
And this is the proof. This is the algebra proof. Now, the y, you got to plug it in, right? So I didn't do that because that's not the point. I just wanted to show you that this formula didn't come from thin air, right? All right. So that is your notes for today. So for today, we're going to start the Desmos, and then you're going to have today and tomorrow to finish it. Okay. So can I have some questions while I load this up? How do you? Why do you? When do you? Anything like that? Can you read any questions on that? This is the good time to ask, by the way. How do you? When do you? Anything like that? Nothing yet? Let it simmer in your mind, okay? Okay, so go ahead and open up the Desmos. And be listening to me, of course. And we're only going to do a little bit, maybe like 10 minutes, and then I'll let you guys finish it tomorrow, okay? Tomorrow I won't be able to be on the computer at this time, but I'll be right here. Okay, let me open up my Desmos. Let's see who's opened. Anyway, this has what we just did has a special name. It's called completing the square, and I'll show you why it's called that. All right, so and wait for my instructions, okay? So I see how many of you guys are in. Let's see how many people are in the Google Meet right now. We have like 15 of us, give or take. Okay.
Entering right now.
Yeah, we're going to go to the pace, Travis, and then click on the Desmos link on today's date.
I already have.
Okay, so watch my screen. Make sure you guys log in with your Google, because if you sign in with the other thing, it doesn't save your information. All right, let me try one. I'm going to pick somebody's. So I'm going to draw a rectangle, and I need to actually make it into a square. So I need to add a little bit here. Is that right? I'll make it a little longer. Now it's a square. So I needed to add this. So this is called completing a square. Can you guys try that? Completing a square, which means make it into a square. You know how we added some number to make it into twins? Well, that's called complete. You're forcing it to become a square. All right, let me see what you guys are doing. So draw a rectangle, and then in a different color or not, add it to make it a square, okay? All right, so this kind of visual. Okay, I'm gonna do one more, all right? This time, draw a funky shape. And in a different color, complete this square. Well, you need to make it in, you need to add what? I need to add this. Right, so now we have a square. But we had to like force it, right? We had to kind of, good job. All right, good. All right, let's do one more. I'm gonna jump on Claudia's. Oh, she's got hers. I'm gonna complete her square. I'm gonna add this, right? Oh, I got to pick a different color. No. All right, good. All right, this time, go ahead and make some room in there. I think you can erase by undoing. It's probably easy, or maybe not. Okay. All right, I'm on yours, Travis. So this time, I want you to complete this square. And then look at my screen because you're going to have to see what I'm doing. Go ahead and complete this square. So you need to fill in this number, this number, this number, this number, and this number. And then tell me what the equation will look like. Okay, I'll leave this open. So everything that's in red here, you have to fill it in.
Okay, so
You could,
since that like on the screen, like I see like you like drawing all this on my screen, and yet like I can't, yet I see nothing on here.
yeah. When I jump on your screen, I can take over your screen, but it doesn't actually write on your screen. So let's talk it through. What is the, if we know one of the twins is x minus 3, what's the other twin's name? Anybody? If you know one of the twins is x minus 3, what's the other twin?
I mean, of course there's going to be a second x.
Yeah, second x minus 3, right? Now you can fill in the inside. Negative, right? Now, 7 is the wrong number. It's supposed to be 9. So how can we force 7 to become 9?
2.
Add 2. And now we have our twins. Ta-da! Is this making sense to anybody?
Yes.
Yeah, it's a little tricky, but you know what? It's I started kind of feeding you guys into the twins for today's lesson, like last week or 2 weeks ago. Okay. All right. Let me see how you guys are doing. So you basically turn and this is called completing a square because you're forcing twins. You're forcing a twins by adding a 2, right? And that's cool because that's your part of your vertex. All right, so let's go to screen 2, and let's see you guys type 2 equations and in the other forms. I didn't actually tell you what this form is named. I figured you might know. But what can you click on to find the vertex? You can click on it and then do it in reverse. Just kind of look at the graph and say, okay, what is it? What's the name of the... so what form is the current function in? What form is the current function in? All right, let's see. I'm going to jump on Nathan's. Okay. All right, Nate went from standard to factored. He said, oh, what, Nathan, you factored or you just click on the x-intercepts? How did you get those numbers?
Just like factored, I guess.
Yeah, you could factor it, right? Or you could just look at the graph too, right? And just kind of do the opposites. All right, so what's the vertex? Can you guys click on the vertex and just see what it is? So you need all three functions, okay? Okay. Let's see if I got all three. Let me see Sophia's. All right, Sophia, good. You got the factor. Can you do the vertex form too? So if you click on the function, you can find the vertex, and then you have all three. Very good. So you should have three functions with one graph, right? It's the same Robotech. It just looks different, but it's the same one. Okay. All right, Devin, good job. So, Devin, you want to do, if you click on, are you doing the vertex or are you doing the factored one? If you do the factored one, then you could just put x and then the x-intercepts, okay? But the opposite, right? Not the same numbers, the opposites of them. And then, Claudia, the vertex is actually 1, comma, -9. Oh, there we go. And then just put squared, or you could just put x minus 1 again, right? Because they're twins. You could just x minus 1 times x minus 1, and then -9 at the outside. Good, good, good. I see 3, okay. And then Travis, there you go. And then you just drop that green one down, okay? We're almost done. All right, and then Travis, take a peek at my screen real quick. Are you doing the factored one or the vertex one?
Trying to do the vertex one right now.
Cool, yeah, right on. So then the vertex is 1, comma, -9. So then you're going to change the inside the parentheses to opposite. Good. All right. Okay, guys. So number 1 from worksheet. So can you guys? And I'm sorry to do this so many tabs. Can you go to the worksheet and to the PACE and open up this worksheet? And I'm going to be typing in a minute. I'm only typed in number 1 so far. I have it open right now. So what I'd like you to do is take number 1 in standard form and then convert it to vertex form using the method I showed you. So you're going to be making some twins and then maybe adding something. And then the thing that you add, you can do it on the outside. You can do it in a different color. And then from that, you can have your vertex from vertex form. All right, I'm taking a peek. Okay. Let me look at Nathan. Let's see. We had so -4 times -4 is actually 16, Nathan, inside the square. And then that means we're going to subtract 12 because we want 16 to become 4. Does that make sense? So inside of your square, it should actually say 16, right? And how are we going to make 16 become 4? We're going to subtract 12 from it. There we go. Good job, Hannah. So now, Hannah, you're going to multiply -4 times -4 for that little square. And that's going to be 16, which is technically the wrong number, but you can force it to become 4 by subtracting 12. Sophia, good job. I like how you added it in red, the thing, right? And you can actually circle both the 16 and the, right, like that. So that you're saying those two together equal 4. And then write the equation on the right side. Okay. Good. All right. Guys, we're only going to do number 2. This is on the next screen. Tomorrow, I'm going to open up the Google Meet, so you guys can join and then talk to each other as you're doing the rest of the problems that I'll put to you for you. Okay. So if you want to, like work together, just log in at any time, except one. No, actually, any time, because this is for you guys only. So just talk to each other and say, hey, let's meet at a certain time, and you can work together. Okay. Very good. Go ahead and do number 2 on the next screen. And the next screen, I just changed the middle term into a plus. Do you think that thing is still going to be 12? Is it still going to be adding 12, or is it going to be something different? Oh, before I do let you guys go, I do need to give you one that has an extra number outside, just to make sure that you guys know how to do it. Okay. Let me just add a number here. Let's give you 2, 6. Let's make it 10, and then 7. Okay. So before you guys do, I do want you to do number 3. Okay. All right. Let's see. So it was the same thing, right? And the reason why it's the same thing, Sophia and Nathan and Deb and everybody, is that when you multiply a positive, you get a positive, but if you square a negative, you're still going to get 16. You're going to get 16 here no matter what, because these have to be twins. So basically, the 16 is always going to be positive, right? So you're always going to either make it bigger or subtract it to make it smaller. Okay. All right. So number 5, when you move, make number 5. You type in your 2 equations. I said all 3, but don't worry about all 3, because all we have is vertex and standard form. Okay, just put two of them. So basically, type your vertex form and then the original, and then make sure that they are correct. And then number 3 is the last one I do want to do, and I promise this is it. So number 3, you have to actually get rid of the 2 first by dividing it. Yeah. And then Nathan, when you get to that extra piece, when you add, you're gonna have to multiply that by 2 at the very end. Good. So you can start with your twins. 2 times. And 2 times 2.5 times 2.5 is 6.25. Now 6.25 is supposed to actually be 7. So how much do you have to add to that, Nathan? Actually, not 7. It's going to be 3.5, right? Sorry about that, Nathan. It's not 7. It's actually 3. It's actually 3.5 because we divided it by 3. But then we have to multiply it by 3. I wonder if you could do that way. Let me try that. Hang on. I'm gonna jump on yours real quick. So this is supposed to be 7. No, it's not supposed to be 7. It's actually supposed to be 3.5, right? Because half of 7 is 3.5. Remember, because we divided everything by 2 first. So that means we have to subtract $2.75, and then times 2. So how much is that? 550? Yeah. Yeah, this was a hard one. Let's see. Good. Good. So this would be 6.25. But these two together have to add up to half of 7, which is 3.5. Okay. There we go. And then anything, and on the last screen, you can verify, right? You can check it in. And good job putting the 2 in the very front of the twins, because that's what it was. And that's how you do it. So basically, for tomorrow, I'm going to let you guys do 7 more of these. And I think it's the same process here. Show me the work, verify with the graph, right? This one was a little tricky, guys, on the because I gave you numbers that became halves and stuff, so they got a little messy. All right. Let's see, 5.5. Let's see, Sophia. Okay. All right, and I'm gonna leave it off here on Sophia's, because these two have to add up to half of 7, right? Which is 3.5. So if you get a calculator and you put you put 625 minus 3.5, you get 6.25 minus 3.5, 2.75. So therefore, I need to add. So this one needs to be minus 2.75, and then times 2, because we divided it by 2, we got to double it. And so that your equation would be 2 times x plus the twins, and then minus 550, or plus 550 rather. All right, everybody, that's all I have for today. I will put 7 more on this Google Doc. And before I put them out, looked to see that they're not too overly complicated. This one got a little complicated, which is good too, but we need to build up as we get here, right? All right, everybody, great job. Thank you so much. Have a great day. Bye.
Oh, it looks like I'm out of here then.
Yeah, let's go. Yeah.